I did a video on solving quadratic equation by first factorizing the left hand side. Now it was done by factorizing by splitting the middle term, but always factorizing may not be possible, or it may not be convenient. So there is a standard way to find the roots of a quadratic equation, so solving the quadratic equation, and that is like, so let's write it in a standard form: ax square plus bx plus c is equal to 0. So of course this is the coefficient of x square, this is coefficient of x, and this is the constant here. So for this equation, a will be 1, b will be 10, and c will be 16, like that. So the roots can be given by an equation, by a formula which is like this. So this is 2a here minus b plus minus b square minus 4ac. So these are the roots basically. There is a plus and minus, so one will be for plus, another will be for minus. Now for a quadratic equation, there has to be two roots because the power of x is 2, so there should be two solutions. Now this part is called, by this part I mean this part is called determinant. So it actually tells something about the nature of the roots. B square minus 4ac, it can have two things. It can be greater than 0, it can be less than 0, three things basically, and it can be equals to 0. So when this is this one or this one, then the roots are real. And when this one is this one, b square minus 4ac is less than 0, that means roots are unreal. That is because we have a negative value here. This one is a negative value, less than 0, and we have a square root, so that the result has to be unreal. So the roots become unreal in that case. However, this is a real root. This is the roots are real, and this is also roots. These two are conditions when roots are real. However, when b square minus 4ac is 0, that means this plus minus part is 0. So in that case, the roots are equal. That means both the roots are the same. So this is how this part of the formula tells us about whether the roots are real, unreal, or whether they are equal or not. And once we have any equation, we can just plug in this formula and get the roots directly, and that's what we should be doing later on in problems. And also this determinant is very important to know the nature of the roots.